Hello everyone, here is distribution of sample proportion. So to find sample proportion, we have p hat equal to x divided by n. This x is number of individuals in sample. And here n is sample size. Okay, so to find sample proportion, we need this x and then divide that one by sample size. Now example number 1. Here on this part in this university, we have 1,045 registered voters. And they were asked whether they approved of the way W. Bush is handling the economy. So 349 responded yes. So obtaining point estimate for the proportion of voters who approve of the way George Bush is handling the economy. And here we have estimate, or in other words, finding sample proportion. So sample proportion is equal to x divided by n. And that is equal to, so x is, so these given, x is 349 and n 1745. So here we have 349 divided by 1745. And the answer is 0.2. Now the next one here, we have a survey of 1,000 adult Americans. So here is 1,000. This is n. And they were asked, are you currently on some form of a low diet? And 150 said they were on diet. So this is x. So n is 1,000 and x is. So find sample proportion. I think this is sample proportion. Here is point estimate. So we have something. So point estimate for proportion. For voters is exactly the same. Asking sample proportion. P hat is x divided by n. There's 150. And here 1,000. Okay, divide. The answer is 0.15. That means 15% carb diet. Okay, next page. Here we have, okay, this distribution of the sample proportion. The shape is When the sample increases, of sampling distribution of sample proportion becomes approximately normal. So when sample increases, this will be approximately normal. Let's have an example here on top. For example, so let's see, this one is normal. If I have for this part sample size n equal to 10, then equal to 0.76. So this is population proportion. And this is sample size. And then I want to increase sample size. N equal to 25, but we have same population proportion. See, what's the difference? Here these histograms are getting closer to this red line. So this red line is normal. Now for this part, and I'm increasing sample size. Now here, n equal to 60. And again, population proportion, same thing. Since here on this part I increase it, I increase it, the sample size, this histogram is getting closer to this red line. So by increasing, this will be approximately normal. Okay, then the mean of sampling distribution equals the population proportion P. Mean of sampling distribution, that is equal to population proportion. Then the standard deviation of sampling of the sample proportion decreases as the sample size increasing. Okay, so standard deviation of the sample proportion is equal to square root of P times Q divided by sample size. So if this part increase, what that means here, this one will decrease. Okay, then on this part we have a solution of, okay, this is P hat for a simple random sample of size n. So here we have a random sample and size is n, with the population proportion is P. We have all these. Sampling distribution of P hat is approximately normal. So that is normal when we have this rule, when we have n times P times 1 minus P, or n times P times Q greater than or equal to 10. Because here 1 minus P is equal to Q. Then next part, mean is equal to population proportion. Exactly what we did here on top. And then standard deviation of sampling distribution is equal root of P times 1 minus P divided by N. We have that one on top, or so instead of 1 minus P, I had Q. So this is equal to square root P times Q. Okay, what we have here, one requirement of that is sampled values must be independent. Okay, independent of each other, that is, one outcome cannot affect success or failure of any other outcome. So it's not affecting. And when sampling from that population, we verify the independence by checking that the sample size n is no more than 5%. So no more than 5% of population size. I'm writing that here. So we have that meaning that the sample size should be less than equal to 5% population size. Okay, so I'm just like have here on this part. So the first one was that sample. Here we have use. These must be independent. Then the sample is from finite population. And this part is based on part 2. So if n less than 5% of the population size, what that means here. Okay, example number 2. Researcher obtains random sample of size 50. I ask them whether or not they already proposes the distribution of p hat, proportion of adults who respond yes. So this is approximately normal. How many more adult Americans does the researcher need to sample? So how many more Americans they need to this approximately normal. So part A, 10% of all adult Americans support the changes. This 10% is P. So this is P, and Q is 90%. So Q is 1 minus P. So recall that we have N times P times Q greater than equal to 10. And the sample size less than equal to 5% of population size. So obviously that's correct because we have the sample size as 50 and we have large population. So obviously 50 is less than equal to 5% of population. So N times P times Q greater than equal to 10. P %, 0.990%. Now finding N. So N is greater than equal to 111.11. Okay, what that means we need so 60 more. is 62. We already had n equal to 50 sample size by and what we need is actually 112. So 112 minus 50, that means they need 62 more Americans. Okay, do the same for part B. Now instead of 10% from part A, here we have 20%. So again, n times p times q. This should be greater than or equal to 10. So n times p is 20% and q is 80%. Solve for n, divide by 0.16. Both sides, and is greater than or equal to 65. Like that, we need 63 Americans. So 13 more. We got that 13 exactly same as part A. 63 minus 50, this was given, is equal to 13. Example number 4. In June of 2008, 2% of registered voters believe that gay and lesbian couples should be allowed to marry. And we suppose that they had simple random sample of 50 voters and determine which voters believe that gay and lesbian couples should be allowed to marry. Describe this sampling distribution. So we need to describe sampling distribution of for registered voters. Okay, so describing that, what that means from previous page, following all those 3 steps. So first I'm writing what was given on this part. S 50, here, sample of 50. And P is 42%. So P is success is 42%. And Q is 1 minus P. So it's 0.50. Okay, so first we should have n times p times q greater than or equal to 10. And also the sample size less than or equal to 5% of population. Okay, so first that one. So we have n times p times q. This should be greater than or equal to 10. For n we have 50. P 42%. Q is 58%. So at this point, greater equal to 10. Okay, multiply all these, we have 12.18. Okay, which is greater than or equal to 10. So yes, so this part is correct. Okay, then I want to find mean. So find the mean. Mean is equal to proportion. And that is equal to 42%. Okay, and then sample, then standard deviation. Okay, so it's then of the sample proportion is equal to square root of p times q divided by, so that is equal to p is 42% and q is 50% and n is 50. Okay, so finding the answer for that, running it, the answer is 0.0698. Okay, so I follow steps and I have these. So what that means, we describe the sampling distribution. And this part computes probabilities of sample proportion. So that is sample proportion. Then here is mean. Mean of sampling distribution. And here on this part, calculation. The standard deviation of sampling distribution. And this is population proportion. Okay, example. See, a random sample of size and 100 is obtained from a population of, here population size is 25,000. And population proportion is 0.65. Now, part A describes the sampling distribution, the sample proportion. So here again, we need to follow all those 3 steps. The first one, do we have normal distribution? It's normal. I can answer that we should have, the first part was n times p times q. This should be greater than or equal to. So here n is 200. P is 0.65 and q is 1 minus p, 1 minus p, 1 minus 0.65, that is 0.5. So here is 0.35. This is equal to 45.5, which is greater than or equal to 10. So this is correct, and the answer part is yes, this is normal. Then second part, finding mean. So mean already given, that is equal to population proportion, and is 0.65. Then third one, standard deviation of sample proportion. Okay, so that is equal to N is 200, P 65%, and here is 35%. Running it, the answer is 0.034. Now, part B, what is probability of obtaining x equal to 136 or more? So more individuals with characteristic, and that is, so we should find this part. Probability of n sample proportions equal to 0.60. So I should find them. So here we have sample proportion. Exactly when we had x, so that was sample. First step was score. Do the same thing on this part. So can we score first? So z is equal to, from previous page we had that. On top we should subtract, so sample proportion, population proportion or mean divided by standard deviation. Is equal to here we have 0.68 for sample proportion minus population proportion from this part is 5 divided by here I have exacting, so divided by standard deviation. So using this part here, and it's 200. Here we have 0.65. This is 0.35. This is equal to approximately to 0.89. Okay, now finding probability is, so p hat greater than 2.68. Instead use z-score. So z greater than equal to 0.9. Okay, so this is so to find the area to the right, we need to subtract, so 1 minus area to the left. We had this part in previous sections. This is equal to 1 minus, using tab, when z is equal to 0.89, area in the body of table 0.813. So subtract, the answer is 0.1867. So z was 0.89, and the area for this part, right cell, is equal to 0.18. $67. Now part C, what is the probability of winning? Here is X is 118. Okay. I forgot to explain that. So how we use this. So 130. Okay, I'm writing that here. This was already given, that's why we didn't need that part. So this 0.68 is 0.36 divided by our sample size 200. Is that one. Now again, same thing, we have 1 divided by 200. What that means, we should find the probability when sample proportion is less than or equal to 0.59. So again, convert to z-score. So z is equal to minus p divided by standard deviation. P hat is 0.59 minus is 0.65. And here on this part we had 0.65, 35 divided by 200. So this negative 1.78. Okay, now finding area. So probability when sample proportion less than 0.59, this is equal to probability when z is less than or equal to negative 1.78. So now instead use z-score. Then use table the area when z is equal to negative 1.78. In the body of table we have this number, we have 0.0375. Previous sections I already told you how to use this table, showing how to use it. So we already have. You know, I'm drawing it. Okay, so as I said in 15, we have this part as 0. On right side we have positive, and left side we have negative. So z is here. Z is negative 1.78. And we should find area when z is less than. So less than this number. Area for this part is 0.0375. So this is the answer. Okay, now I want to explain what that is. So about for Okay, so this was the area on left side. Now, number 6. Let's suppose we have, 29% of adults do not own credit card. Part A, suppose we random sample of 500. Let's ask, do you own a credit card? Describe again, we need to describe sampling distribution of this, so that is p hat, sample distribution. And the proportion of adults owning credit card. So again, all those 3 steps. So the first part is that, do we have distribution? So is this normal? We can answer that. That do we have n times p times q greater than or equal to 10? We have that one. Okay, so n times n we have 500. So 500 times p is 29%. So using that p, q is minus p, so it's 0.71. So here is 10.229, and this is greater than or equal to 10. With that, this one is normal. Okay, I should find mean and standard deviation. So mean, this is already given, is equal to population proportion as 29. And standard deviation. So is square root of pq divided by n. .500, p is 0.29, and q is, okay, that is 0.020. Now part B, what is it? That in random sample 500 adults, more than 30% do not own a credit card. So probably when this sample proportion is more than 30%, so greater than point. So more than 30%. Convert to z-score first. So z is equal to p hat minus p is 29% divided by standard deviation. So divided by 500, and on top we have 0.01, denominator 0.0203. So that is equal to 0.49. So using this z-score here on top, finding the probability band z as, here we have greater than, so I have greater than 0.4. This is right tail, so to find the area to the right, you need to subtract 1 minus the area to the left. So using table when z is equal to 0.49, area is, the body of table is 0.879. So subtract, the answer is 0.31. So this was the 0.49, and the answer that we got was for part area to the right. What that means, okay, they didn't ask us to interpret, but I'll write that. So this means about, here we have 31%. It's approximately equal to 31%, so about 31 of the 100 sample of size 500. Will result in more than 30% no credit cards. Now, Parsi, what is it that in 500, the between 25 and 30% do not only credit card. Now, on this part we have between, I don't have right or left. So finding the probability when the sample proportion p hat is between 25%. Again, convert to z-score. First, finding this part 25, or p hat minus p is 0.29. So this is from previous part, 0.29 was given. Divided by standard deviation from previous part here. This one is 0.023. So that is equal to negative 1.97. Now for right side, z is equal to, here is p hat is 30% minus p by standard deviation. That is 0.49. So here find probability when z is between negative 97 and on this side 0.49. Okay, so again, use table. Z is equal to negative 1.97, and also when Z is equal to 0.49. So for when Z is 0.49, I have 0.6879, then minus the probability for this part. So when Z is negative 1.97, is equal to 0.244. Okay, subtracting, the answer is 0.6635. Okay, so here Z is negative 1, and here's the 0.49. And that answer was for the in between these two scores. Part D, would it be unusual for a random sample of 500 adults to result in 125 or fewer do not own credit card? Okay, for this, so I have 125 or fewer. I don't know what sample proportion. So first, I need to find that part. Remember, I told you, so this was given, where is that? This was given x 118 and also sample proportion. That's why I didn't work on finding p hat because this p hat was already given. But in this part, I don't have p hat, so finding p hat using this x. So p hat is x divided by n, and 125, 500, this is n, this is x. Okay, the answer is point. Probability when p hat, so this is fewer than, we have less than. Then to z score. Okay. So z is, p hat is 25%, p is 0.29, divided by, from this part, the standard deviation was 0.0203. So it's negative 1.97. So less than negative 1.97. Use table, this is the area to the left. And the answer is 0.0244. So it's asking if this is unusual, since this 0.244 is less than this 5%. Therefore, this is unusual. Okay, so this part is unusual. We finished this section. Hope you enjoyed this one. Bye-bye.